First of all, a few definitions about circular measure and the circle. We're going to end up defining the radian in a minute. But before we do that, if I draw the radius out from the centre of a circle and then draw the radius again, that area, this section here that I've taken out, is a sector. It's called a sector. If I just cut a piece out of a circle but don't go to the middle, then that's not called a sector. So if I take out a chunk like that without going to the middle, then it's not defined as a sector. That's just a segment of the circle. And we're not interested in segments. We're interested in sectors where I've drawn from the centre of the circle. This distance measured around here is called the arc length around the side of a sector. And so there are some definitions for them. We're going to end up with some formulae to enable us to find the area and the arc length of a sector. The radian comes into it too. The radian is this measure of the angle in the centre. And it was defined where if I were to measure out this radius and this radius here and then make sure the arc length here is exactly the same as the radius, then that's defined as 1 radian. So 1 radian is subtended, we say, an angle of 1 radian, when the arc length equals the radius. We've got 1 radian. And if you've got that done, then if we think of a whole turn in a circle coming right round a circle, then that's 2 pi lots of the radius. And if we define 1 radian as the radius, then 1 complete turn is 2 pi radians. So 1 turn is 2 pi radians. And that's an important thing to remember. If we measure angles in radians, 2 pi radians is a complete turn. And we know that that's 360 degrees. So straight away we've got the conversion factor between radians and degrees. 360 degrees, which is a complete turn in degrees, is equivalent to 2 pi radians, and rads or rad radians. So once we recognize that 360 degrees is 2 pi radians, well then 180 degrees is pi radians. So we've got that. Now if I want to go from degrees to radians, what I really need to know is what 1 degree is. So if 180 degrees is pi radians, what do I do to get 1 degree? Yeah. So the conversion factor is I just multiply my angle in degrees by pi over 180, and I've got it in radians. So for example, 35 degrees is 35 times pi over 180. And that's how I convert. What does it come out to be? So 35 degrees, 0.61 radians. There's always going to be some rounding associated with that because pi is one of those irrational numbers. It's a never-ending decimal. So we're always going to have to round it to an appropriate degree of accuracy if we want it in radians. If we want an exact answer in radians, what we tend to do is leave it in terms of pi. And that can sometimes be useful. For example, if I want to know what 90 degrees is, that's 90 times pi over 180. But 90 over 180, 90 goes into 180 twice, it's just pi over 2. So 90 degrees is pi over 2. And we often leave it like that. We don't bother to work out what pi divided by 2 is, because then we're introducing a decimal that we're having to round. So we leave it in terms of pi. Often a convenient way to write it, as then the more you do on these things, the more you'll see that that's the case. If we think back to our circle, a complete turn was 2 pi radians. You might have been able to tell me that 90 degrees was pi over 2. Because if 360 is 2 pi, 180 would be pi, so therefore 90 is pi over 2, half pi. What would 45 degrees be? Pi over 4. So there are a few key angles that it's worth getting to know. Okay, so how about radians to degrees? What we need is what 1 radian is. And as before, if we know that 180 degrees is pi radians, what do we do to get what 1 radian is? Pardon? Divide by pi. So it's 180 divided by pi. That's the conversion factor. So if I want to go from radians to degrees, I times by 180 and divide by pi. For example, 1.5 radians is answer 85 degrees to 2 significant figures. Common with these things to round to the nearest degree. We're not often interested in parts of a degree. Sometimes you are, but it depends on the scenario, but often nearest degree will do. So 1.5 radians is 85 degrees, near enough. Okay? So we can convert from degrees to radians and radians back to degrees. And it's worth remembering what certain key angles are, like 90 degrees, in radians. 90 degrees is pi over 2. You don't need a calculator to do that. You just remember it, because you know that 180 degrees is pi, so 90 must be half that, and so on. Having defined what we mean by the sector of a circle, which is a section taken out, drawn from the centre of the circle, then we're after formulae for the arc length. Remember, the arc length is the distance around the outside of the sector, and the area of the sector. So the two formulae that I'm just going to give to you, but it's actually not that difficult to see where they come from, and in the textbook it outlines that to a certain degree. The arc length, and we use S to represent the arc length, it's just the radius multiplied by the angle. And the area is just a half times the radius squared times the angle. But in both cases, the angle must be measured in radians. If it's not in radians, you don't get the right answer. Because of the definition of the radian and how that's associated with the sector, then that means that actually finding the arc length and the area is straightforward, so long as the angle is measured in radians. So here's an example. Find the arc length and area of a sector with a radius of 1.9 centimetres and an angle of 45 degrees. So you use that formula, the two formulas above rather, one for the arc length and one for the area, but angle has to be in radians, so you first of all convert that angle to radians. You don't actually need a calculator for the conversion. 45 degrees you should be able to do, and then you just use the formula and come up with the values. So converting theta 45 degrees into radians, it's pi over 4. And then plugging those values in, we get arc length and area. So if you just put those numbers into the calculator, we get an arc length of 1.5 centimetres and an area of 1.4 square centimetres to two significant figures. Okay? You'll be able to, asked to use formulae like that. Certainly you will in the assignment.